Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying marine auxiliary systems and deck machinery. Today we have fourth lecture and the topic is Rotary Displacement Pumps Part 1. In this tutorial, we will discuss about the gear and vane pumps. Rotary displacement pumps are preferred than reciprocating pumps as they are able to provide large flow at steady rate and pressure. Rotary machines can be operated at higher speeds which make them compact for the same rate. Rotary pumps have simple construction in comparison to reciprocating pumps and are very compact. Various types of rotary pumps have been developed which have rotors of special geometry. In comparison to reciprocating pumps, these are less efficient because of the large areas with running clearance exposed to differential pressure between suction and discharge. Wear increases the clearances with consequent loss of efficiency, especially when handling low viscosity fluids. Let us discuss these through the following slides. Gear pump. This sketch shows the construction of a gear pump. The pump consists of cast iron housing equipped with suction and delivery ports. The housing encloses two gears having spur or helical profiles and mesh with each other. Gears are hardened by nitriding process all over and ground finished after hardening. The gears are driven by a stainless steel shaft which may either be attached by a key in large pumps or integrally forged for small pumps. Shafts are supported in the pump housing or end covers by bushes or bearings. Bushes and gears are lubricated by the oil being pumped. The gasket seals between the pump housing and end cover on the free end. A gland packing, lip or mechanical seal prevents leakage of oil on the drive end. The pump shown in this sketch is attached to an engine or auxiliary machine with the mounting flange. Large pumps are equipped with footing for securing on the floor. Gear pump operation. The sketch shows the cross section through the pump casing with internal drill passages. Gear pump is the simplest type of rotary positive displacement pump used for transfer of fuel and lubricating oil and also for lubrication of medium and high speed diesel engine or gearboxes. Oil is carried between gear teeth and housing. Centrifugal force created by the rotation of gears contributes to the pumping action. There is no side thrust with straight gear teeth. However, side thrust produced by single helical gears causes severe wear in bronze bearing bushes and gears become actually displaced. Thus, a double helical gear is preferred. Excessive clearance between bush and shaft will result in drop of performance due to wear of gear profile. For smooth operation of the pump, there should be clearance of zero point 0.2 to zero point 0.5 mm between the gear teeth, which is also called as backlash. Without proper backlash, the pump will not operate properly, resulting in loss of power, additional load on bearings, spreading of the gears, and heating of liquid. Oil is admitted from the inlet port due to the suction created by the pump, moved between the cavities formed by gear teeth and casing, and delivered from the outlet. A relief valve equipped on the displacement pump relieves the excessive pressure caused by restriction in delivery line by returning the liquid to the suction side through internal drilled passages. Internal gear pump. The sketch shows an internal gear pump, also called as a trochoid pump, which is used for small applications. The pump consists of a casing equipped with liquid inlet and outlet connections. The pumping element consists of an outer or drive gear and an inner or driven gear, which rotate in a renewable liner fitted in the pump body. The inner rotor is eccentric to the outer, separated on one side by the crescent, attached to its shaft and located by bearings in the pump covers. Rotation of the inner rotor creates a pocket of increasing capacity between the rotors on the suction side and a corresponding decrease on the delivery side. This results in the pumping action and draws the fluid into the pump through ports in the outer rotor while the pocket is increasing in size and forces it out of the opposite side of the pump when the pocket is decreasing. Internal gear trochoid pump. Let us see the pump operation through animation. We can see that both inner and outer gears are rotating in anticlockwise direction. An increase in volume on the left side causes liquid to enter and leave from the right side where the volume is gradually decreasing. The incoming liquid gets trapped in the cavities formed between outer gear teeth and crescent and inner gear teeth and crescent and get carried to the outlet side. Now let us see the maintenance of gear pumps. Maintenance of gear pump. Gear pumps provide trouble-free service with minimum of maintenance. Daily inspection. Pump should be checked daily for noise, vibration and leakages. 6 monthly inspection. Coupling bushes are checked for wear and renewed if necessary. Annual inspection. Pump should be dismantled to check wear of the bronze bushes annually. At the same time, check clearance between the gear in the casing and condition of mechanical seal. 5 yearly inspection. Pump is surveyed every 5 years when pump may be dismantled completely or the surveyor may give credit by carrying out running trial only. This completes the study of gear pumps. Vane pump. Vane pumps have fixed delivery and were earlier used for hydraulic systems in open circuit with directional control valves. With the advent of variable delivery pumps, nowadays these pumps have lost their popularity on the ship. The sketch shows the hydraulic circuit diagram of a vane pump to explain its working principle. Pump consists of a rotor which is usually operated by an electric motor. Rotor consists of a number of slots in which vanes are inserted. Pump consists of an oval-shaped cam ring surrounding the rotor to which the vanes make contact and slide in and out 2 times during each rotation to create the pumping action. Vanes are made up of stainless steel and their contact surface with cam ring is provided with synthetic material seal to prevent metallic contact and oil leakage. Vanes are thrown out due to the centrifugal force imparted by the rotor movement. Two sets of diagonally opposite inlet ports supply oil between the vanes and the cam ring when the volume is increasing. Similarly, two sets of diagonally opposite ports collect the oil carried by the vanes when volume is reduced and discharged from the outlet. Two sets of ports are helpful in balancing the thrust. This picture with cutaway section shows internal details of the pump such as rotor with vanes, shaft, mechanical seal and cam ring. Oil enters the pump through left side and discharge from the top. Relief valve relieves excessive pressure from delivery to suction site. The construction and operation of axial piston pumps used nowadays will be discussed in the chapter of deck machinery. Second part of rotary displacement pumps will cover screw pump and their characteristics. This book is written by me and covers all the topics as per syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exams and also to work on ships, auxiliary systems, and deck machinery safely. Hope you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You must subscribe to the channel for getting notification about the new tutorials. I'll be back with a new lecture shortly. Thanks for watching till the end.